Okay, chapter 12 is 3D images, 3D pictures, called polyhedra or polyhedron. But you need to know what classifies a polyhedron. So up on the board, I've got an example: a prism, a pyramid, and who knows. But it's still a polyhedron. Polyhedrons have to be made of polygons. We already had a chapter way back when on polygons. In order for it to be a polygon, it has to pass, I want to say, 2 tests. No curves. So do any of those pictures have curves? And then it has to be closed. No like open spaces. So like a triangle that doesn't close all the way, that wouldn't work. Does that make sense? So just watch out for curves. Watch out for unclosed spaces. All right, we have a whole page of vocab, right? Whew. Reminder, do we have to write everything that's on the board? Please no, be nice to yourself. Let's help you. The first one, this is pretty legitimate. So polyhedron, solid is bounded by polygons that enclose a single region of space. Yeah, you could write that, but it's kind of what we just barely talked about. Make sure there's straight lines. Where do I want to write this? All right here. Straight lines, and it's always closed. Now when I say closed, does that mean it can be convex or concave? As long as it's a closed shape. Okay, let me redeem myself. Guys, next to your vocab words, will you draw your own cube? Do you know how to draw a cube? Alright, so box in the front, yeah, see through. Box in the back. Connect, 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 connect. Just like we did in the warm-up, let's describe face, edge, vertex. That's what today's lesson is mostly about, but it's mostly about counting the faces, edges, and vertices. Okay, so a face, I'm going to color it in white. Here's a face. Let me write it. Guys, how many faces does this shape have? Agreed. Lots of people say 5, because they forget the bottom. So it has 6 faces. Now, what if you had to describe the faces on this? What shape is each face? Square or rectangle, right? If it's not the most perfect cube. All right, edge, I'm going to use, how about blue? Edge would be like this part right here. Literally the edge of it. Do you remember from the warm-up, how many edges are there? 12 edges. Okay, and then Callie took care of the vertices for us. Just going to highlight this one in orange. So here's a vertex, plural vertices. How many are there? 8 corners of the box. Again, today is about counting faces, edges, vertices. How many of you, yeah, I got these ones. Pretty nice. We've gone over these before. Okay, let's see what's next. Oh, regular polyhedron. Polyhedron whose faces are all congruent, regular polygons. If it was my notes, it would probably be there. Faces are all congruent, regular polygons. Emphasis on those regular. While you're writing, what does regular mean again? Perfect. Equilateral, and do you remember the word for all angles equal? Yeah. Good job. Okay. We learned a while ago about convex, and there was another word that goes with it. Do you remember? Convex, concave, which is which? Concave. Perfect, perfect. So convex is the one that doesn't cave in, right? So I'm just going to put doesn't cave. Now, I got more descriptive because you guys are geometry students. Doesn't cave means you can go from a vertex to a vertex and it always stays inside the shape. So for example, on this, if I go from this vertex to this vertex, does it stay inside the shape? Okay, but does that happen for any vertex? You just gotta check it. That means it would be convex. All right, so this one, convex. What about number 2? Convex. Okay, what about number 3? Concave. It kind of interchanges between non-convex and concave. Guys, just practice the concave. All right, let me show you why. From this point to this point, does it stay inside? No. Oh wait, but if you read the directions, it says decide whether the polyhedron is regular and or convex. So let's go back to number 1. Oh, what do you think about this one? Do you think it's regular? No? Check the sides first. Are all the sides equal?
Yes.
Okay, it passes the side test, so it's equilateral. What about equiangular?
No.
I agree with you. Because like right here, these kind of look like what degrees?
90.
Right? Whoa. What about this one? Does that look like it's 90 degrees? All right, so again, it's interchange. I've seen non-regular and irregular. You'll see this more in your life. Irregular. Okay, what about number 2? Regular, irregular? Regular. Are all the sides equal? If all the sides are equal in a triangle, what are the angles equal?
60.
Yep, so this would have to be regular. Whoa. What about number 3? Irregular. Because of what? Sides or angles? Angles, totally. Okay, guys, good job. We saw more vocab, huh? Let's see what's next. Oh, cross section. These are kind of hard if you have to draw your own. Cross section, if you don't want to write that in, it's just an intersection. These are examples of cross section. This is a cross section, and this is a cross section. The actual cross section is this. I'm going to highlight in red. What shape is that? Just the cross section. I agree with you. So if you have to describe a cross section, just name what it looks like. Okay, this one over here, what do you think this one is? Parallelogram is probably super safe, right? But it might be a rectangle. So cross section, it's a solid that's getting cut. But what happens when it gets cut? A shape comes out. Sometimes you have to describe the shapes. Okay, next part. I find this fascinating. There's a guy named Plato. Found this. There's Plato, Greek philosopher, mathematician. He came up with the 5 platonic solids. So on your notes, put down that there's 5 of them. First one is the tetrahedron, and then the cube, and then the octahedron, dodecahedron, and icosahedron. That's it. Just write down 5 platonic solids and then list the 5 of them. Platonic solids are fantastic because they're all regular. What does regular mean again? Equal angles, equal sides, right? Okay, so let's break down 10 faces. 4 of them. So I just put 4 faces. Now I found examples of each. This is the tetrahedron right here. Each face is what shape? Triangle. So it's made up of triangles. You might want to write that in there. Super stretch. Triangle faces. Octahedron, guys, you got this. How many faces does the octahedron have? Has 8. Is the octahedron. So its faces are what shape? Triangles again, right? It's like a tetrahedron on top of a tetrahedron. 8 faces. They're also triangles. This one's like the odd man out. Dodecahedron has how many faces?
12.
But what shape are they?
Pentagons.
Pentagons, which is like what? I almost said it out loud. Athletic item. Yes, Calvin, thanks. Soccer ball. 12. They're all pentagons. Last one, icosahedron. Icosahedron has how many faces? 20. And they're all what shape? Triangles. What I'm hoping we can do after the CRTs is make these shapes, like literally 3D shapes. They are fun to make. Funny? Fun. What I should have done is I should have done it over Christmas so you can make ornaments. Yeah, for trees. All right, are you ready for the next part? This is just a, hopefully you already know. Here's, what is this called? This one? This one? There's a better name for this. What's the base of the pyramid? So it's called the square pyramid. You always name it by the base. This one? This one? All right. Okay, A, B, and C. Guys, will you try to figure out how many faces, vertices, edges they each have? Draw on your shapes, count them out. Okay, letter A, you've got this. Letter A has how many faces? I agree. 6. Yes, 8 corners. So how many edges does it have? Perfect. Have you gotten to letter B yet? Yikes. How many faces does letter B have? Is it 8?
Yeah.
I agree. Okay, so 8 faces for this one also. Alright, vertices, how many corners do we have? Are you sure? I have to count them out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sounds good to me. 12? Alright, then how many edges does it have? 18? Okay, let's stick with 18. Letter C, don't even bother counting them. How come? Why is it not a polyhedron? Curvy. No curvies. Can I peek at something because I want to teach you? And for whatever reason, or you just don't feel like counting something out, or it's the most ridiculous picture and counting it out, you're afraid you're going to mess up. There's a formula that takes care of it. It's called the Euler's theorem. Wait, or formula. Anyway, it's Euler who discovered it. Who discovered it? Euler. It's like a weird word. Here's the formula. I would write it down right on this part. The formula is not too bad. It's F plus V equals E plus 2. It is on the reference sheet. Confession. My very first year of teaching geometry, I asked the other geometry teacher who had been here forever, I said, do we need to teach Euler's theorem? And I didn't see that till college, and she's like, nah, don't worry about it, it's never on the test. Guess what was on the test that year? Ugh, Euler's, I felt terrible. But the kids were like, no, we got it. And I was like, how did you figure that out? And they're like, it's on the reference sheet. So, perfect. What does the F stand for? B? E? Right here, this is what gets forgotten, the plus 2. It just kind of random out of there. So we can check these. Right here, 6 plus 8 is what? 14. 12 plus 2, is that 14? We got it, we did it right. This one, 8 plus 12 is 20. 18 plus 2, is that 20? So we got it. We did good. We did great. Okay, here's a review. You handle this. A, B, C. Are they convex? Are they regular? Try it first. Letter A. Convex. Convex, it should say concave, right? Alright, regular or irregular?
Regular.
Whoa, let's start over. Convex. There's a name for this. You just barely learned. For this shape. Triangle doesn't cut it. What is it, guys? It's a tetrahedron. Good work. Alright, letter B. Convex or concave? Regular or irregular? Totally right. Are those sides even kind of equal? No. Alright, letter C. Convex or concave? Concave. Regular or irregular? Irregular. How many of you are hoping for lots of those type questions? Easy enough? Yeah? Okay. There's Euler's theorem. Euler's theorem. There's Euler. Yikes. We've got F plus V equals E plus 2. Don't forget the plus 2. You have to add 2 to the edges. Got it? Okay. Let's use Euler's on this to figure it out. Okay, Euler's theorem, F plus V equals E plus 2. Faces. How many faces are in this shape? Oh, it tells you in the directions. Did you notice? 10 right here. Helpful to read those. So 10 faces plus, we don't know the vertices. Edges. How many edges do you think are in there? Let's just go on the top. How many edges are just right here?
8.
Okay, so how many would have to be on bottom?
8.
Don't forget these ones. How many do you think would be right here then?
16.
I don't know. Just think you've got 8-sided shape right here, and you've got one line coming from every corner. I agree. Don't you think it'd just be 8? Even though it's hidden behind it? So altogether, how many edges? Well,
24.
there you go. Altogether, 24 edges. Okay, I'm going to add in a step. This is like super basic algebra. So now we have 10 plus V equals 26. Think to yourself, well, plus 10 will give you 26.
16.
There you go, you're done. So there's how many vertices? 16. Euler's theorem comes in handy when you have crazy shapes to figure out. Or like this one where it's hidden. It's not a see-through shape. Okay. This one. Jump to number 4 in your notes. Is it possible for a polyhedron to have 16 faces, 34 vertices, and 50 edges? Curious, before I do anything, how many people vote yes, possible? Okay, hands down. How many vote no, not possible? Really? How are you going to show it? Tyler, what are you going to do?
Well, you could just set it up 16 plus 34 plus 6 plus 2.
Okay. So you use Euler's, and thanks for not forgetting the plus 2. So this is f plus b equals e plus 2.
Yeah, that can't work because 6 plus 4 is 10. 50 does not equal 54.
50, wait, that's not equal. Aww. So is this shape possible? No, not possible. Alright, you did great.